Hi, we are team number 8. We are Luis Ernesto Íñiguez, Jorge Alberto Chavez, and me, José Morales. And we are going to talk to you about the activated carbon's role as the main agent in wastewater restoration. To begin with the presentation, we want to talk to you about the abstract. We make this project with the intention of contributing to the world wastewater issue, an accessible, effective, and homemade solution that was elaborated with the activated carbon as main agent. For this solution, the physical properties involved in the process of absorption of activated carbon over wastewater were investigated. We make previous investigation and we analyze the better situation to make these filters. And we create some water filters. They were 4 and they were 12 atoms. And with these theoretical calculations, they indicated a correlation between the grammage of activated carbon with the levels of pH and conductivity found in the resulting water. This experiment corroborated that the connection and confirmed the existence of an ideal range of mass for achieving optimal pH and conductivity levels. Now, with the introduction, we are going to show you how is the situation worldwide with the water restoration. So, as we know, the Earth has several difficulties related to water and its usage. The problem is that this basic life resource is scarce in many communities, which practically denies millions of people the chance to survive. More than 80% of the residual water resulting from human activity is dumped into rivers, lakes, and seas without any kind of treatment. So having this in mind, that we waste over 1.7 trillion gallons of water per year, several things need to be done, and that's why we decided to make this. Water generation, treatment, and reuse processes are among the solutions because they are efficient and viable, but unfortunately, worldwide, only a minority of these communities can be able to make these changes. So, alerted by global challenges that human faces every day, we decided to search about the Sustainable Development Goals of the United Nations and inquire about the 6th goal about clean water and sanitation, because we think it's one of the main problems that are affecting at a global scale. We know that water is essential for life, and it has a very bad administration and distribution among communities. Bad quality of water, specifically in those who suffer poverty and extreme climate conditions, they are affected. So we pretend to create a useful, simple, and accessible water filter based on the element of activated carbon in order to clean water and turn it into perfectly adapted water that can be used in daily life as drinkable water. We are using activated carbon because it's the ideal water filter material because it removes toxins without stripping the water of salts and important minerals. So it maintains like the most important things of the water that we need as humans. The filtering property works through the process of absorption. This process binds impurities chemically of the surface of the charcoal filter rather than physically absorbing them. The removal takes place through absorption phenomena based on surface interactions between contaminants and carbon-graphic platelet surfaces. Also, to determine the need for treatment and the correct treatment technology, specific contaminants in the water must be identified and measured. Suspended solids such as lead, sand, and viruses are generally responsible for visible impurities. They can be identified by describing the visible characteristics of water, including turbidity and clarity, taste, color, and the odor of water. Water quality can also be determined by a number of quantitative analyses in the laboratory, such as pH, total solids, conductivity, and microbial contamination. pH is the value that determines whether a substance is acidic, neutral, or base. The calculation of the pH is from 0 to 14, and the middle one, the 7, is the neutral substance. So the conductivity means the conduction of energy by ions. Measuring the conductivity of water can provide a clear view of the ion concentration in water, as water is naturally resistant to conduction of energy. Conduction is expressed in Siemens and is measured with a conductivity meter or a cell.
And well, from our theoretical calculations, we came up with the hypothesis that more activated carbon put into the filter would remove more toxins. And consequently, chemical impurities and other contaminants, and therefore the water would have more chance of being drinkable. For the experiment study, the pH and conductivity measurements, as well as the qualitative results, were obtained from 4 different water filters made up with the following order, as you can see in the presentation. Like, for example, cotton, small rocks, gravel, activated carbon, sand, and water filter. We poured slowly 1 liter of water on one side of the bottle, waited until the liquid trespassed all the levels of filtration, and we recompiled the resulting water from the soda bottle in a container and checked how much water was filtered. And with a sample of the filtered water, we did a water quality test that consisted on obtaining the pH and the conductivity. As my partner said, we measured all of this in microsiemens, as well as we revised the qualitative aspects of it. To obtain both pH and conductivity, we used an electric conductivity meter. The experiment consisted of 3 repetitions for each of the 4 different filters. The first filter, as you can see in the image of this presentation, had 80 grams of activated carbon. The second one had 120 grams. The third one had 230 grams, and the fourth filter had 300 grams of activated carbon. These 12 different attempts were done overall. And after the experimental section, we obviously recompiled the data for its further comparison and analysis.
Okay, thank you. As my partner said, we divided these observations into 2 groups that are the qualitative and the quantitative data. So for the qualitative data, we have a chart at your right that, as Luis said, there are 4: turbidity, odor, taste, color, and transparency. Uh, Sorry, Josue said that. But overall, this table of telling which filter complied or not complied with each of these qualitative characteristics was very important for us to have a safety protocol that basically is what made this experiment safe for us, the ones that were doing the experiment. And after these observations, we could see that filter 1 and 2, that as you can see, only approved on one characteristic, that was odor, that was completely neutral. The other ones were not approved, that because turbidity, color, and transparency had a very not optimal form or color. For example, turbidity, they were full of contaminants, and we could see that very clearly. And for the taste, we didn't even make the taste proof, because they were not complying with the other things. So for safety reasons, they were not tasted. But we can see that filter 3 and 4 do comply with all of these before mentioned characteristics. And with that, what we succeeded was in having 2 different categories inside the qualitative results. First, the one that is approved and then therefore is drinkable, and the ones that are not approved and therefore they are not drinkable or undrinkable. Filter 1 and 2 are not drinkable or undrinkable. So that means that they can't be classified as possible candidates for the next round, that is going to be the quantitative data. Therefore, they are not considered, and then only we stay with filter 3 and 4 that need to be analyzed. Now, before mentioning the quantitative data, that is the most important part of the experiment, we need to establish the standards that we're going to measure them with. That is For the pH, we need a 6.5 to 8.5 level of pH, and from a 200 to an 800 level of microsiemens. For example, in the conductivity test that we did, as you can see in the graph, in the first graph in your right, we can see that filter number 1 and filter number 2 have a very huge gap of difference among numbers. 3,000 to 100 is a very big difference in conductivity, and therefore we can see that there is a decrease in microsiemens, and that is caused because when you put more activated carbon, you receive a less quantity of microsiemens. That is because the conductivity goes down, and that is beneficial in most cases. But as we can see, we have in the conductivity test two values that are not in this range. That is filter number 1 and filter number 4. This causes that they can't be considered as optimal drinkable sources. Even though 118 isn't very dramatic and it could be considered, we are putting it away, the filter number 4, because it doesn't comply exactly with the 200 to the 800 microsiemens range. So that gives us that only filter 2 and 3 are the ones that could be drinkable or could be standards in the drinkable characteristic. Now, for the pH level test, that was very important too. Also, we measured it with the conductivity meter, and that gave us a different result. Basically, the filter number 1 and number 2, that number 2 was okay in conductivity, but it isn't okay in pH. That meaning that 1 and 2 that were all already cataloged as undrinkable in the qualitative side are also non-drinkable in the pH level side. So that gives us only the 3 and the 4 filter that have an acceptable pH level. So basically what that means is that for the conductivity test, we see that we need a minimum of 230, sorry, for the conductivity, we need a minimum of 230, but a maximum of approximately 300. We don't know exactly the value because we didn't have the time. So all that we can say is that we need something lower than 300 because that gives us a value under the range. So basically that is for the conductivity, and for pH, we need a value only higher than 230 grams of activated carbon, as the 230 grams is the amount located in the filter number 3. So finally, in these results and discussion, we can say in simple words that filter number 1 and 2 that were already cataloged as undrinkable in the qualitative side, they are not well. Filter number 2 can be considered in conductivity test, but again, in the pH level, it doesn't include the correct values. So filter 1 and 2 were undrinkable from the beginning. Filter 3 had the best results, and it shows that it is the optimal filter to be created. And then filter number 4 doesn't comply with the conductivity minimum requirements. So that means that it is also in the undrinkable side. But conductivity isn't that big of a deal. So it could be drinkable, but for the manufacturing side of this water filter and for making it at scale, it couldn't be the filter number 4, so less than 300 grams, but bigger than 230 grams. Lastly, as the part of our conclusion, we could say that our hypothesis isn't correctly nor wrong nor right. It only gave us a very specific side to see and to search for an answer. That is, more carbon or activated carbon inside the water filter doesn't necessarily mean that it will be a better quality of water. But what gave us as an acknowledgement is that we need to delimit this grammage of activated carbon. And that is very important because without delimiting a range of grammage, things could go wrong, as we see with the filter number 4, that conductivity really was going down. And we think that if we continued with the experiment with more activated carbon, the conductivity would go very down to unnecessary and non-drinkable levels. And then for pH, it would go up, but we don't know to what exact point. So yeah, due to the nature of the experiment, we didn't do that, but we could make these conclusions very, very accurately. So lastly, if we could establish this experiment with a simple phrase, what we learned about it is that with If the amount of working activated carbon increases, the pH levels of water increase, the conductivity value decreases, and the removal of contaminants is more effective. So what we can say lastly is that we need to limit this grammage of activated carbon, and also we need to check what type of filter we are dealing with, and what size, and what is the purpose of it. If it is an industrial filter, it can't be 230 grams to 300 grams. It needs to be experimentally studied and also determined with the knowledge of what is the volume that the water filter will take, and lastly, what type of filter it is. So that was our experiment. If you want to check out this scientific article, please check this link down here. And we hope that you liked it. If you're interested, please check this article and we can start a conversation. Please check our reference too. And thank you very much for attention and have a very good day.